Welcome back friends. Today we will continue again the first chapters. I am not a professor, I am not a lecturer, I am not a teacher. I am a self-learner. I want to share my knowledge to my juniors by self-study. Friends, this is the chapter number 1, the introduction of the machine designs, and this is lecture number 2. So friend, we will recap what the last lectures we have studied. We didn't the machine design. What is the machine design? We studied machine design is nothing but it is making a plan, okay, and to make a new machine or maybe improve the machine with existing machines. This is the machine designs, and the types of machine design also we studied. The types of machine design, one is we studied the adaptive designs, one developmental designs, and a new design. Adaptive design, the designs works on concerned with the adoption of the existing design. The design is already existing, and you have to make the modify. The design role to make the minor alteration or the modification of existing designs of the product, that we already told that already in the flat belt drive, the belt design you already know. The where your application, the power transmission or conveyor, or where your application based you can use it. The developmental design, this type of design needs the considerable scientific training and the design of ability in order to modify the existing design into a new idea by adopting a new material and different method of manufacturing. The design starts from the existing designs, but the final product may be different quite marketed from the original product. Means example, the car designs, day to day the design of the car is changing, right? And a new design, this is entirely it is different, it is starting from the scratch and not scratch, and this type of design a lot of research and technical ability and creative thinking. Already the existing principle is available, but you have to take the principle and you have to do that, okay. The classification of machine design also based on this method. The rational methods you can take the stress and the strain formula is available, you can find out, and the stress and strain, you know, the empirical stable load by area, you compare with this result with the standard. The empirical designs, I altered empirical design formula, and based on this empirical value, actually you cannot calculate it by the formula. By the experience you are making some formulas. Example, the bolt and bolt nut joints, when you are tightening with the bolt, some preload will come to the bolt, that is I already told P is equal to 284 D Newton. So how based on the diameter of the bolt, you can calculate how much force is experienced in the bolt. This empirical formula you can use. The industrial design, based on the industrial's norm and industrial's availability resource, you can make the designs, okay. And also with general consideration, we already know types of general consideration in the machine design. Also you told there is some 12 point you have to consider while we are making the design. The type of load and stress cause the loads, and you have to calculate the stress and strains, and that cause the loads. You have to take the one important parameter in the motions of the part. If it is a motion will be the simple, if it is smooth motion, then it is good for the design point of view. That may be curvilinear or maybe rectilinear or constant velocity or constant acceleration type of motion. You have to find out the selection of material. This is one important thing for machine design of view. So material, the designer should know the property of the materials and where your application, the field of the application of the elements based on the mechanical strength, the stiffness, ductility, malleability, the durability of the material. You should know where you are using the form and size of the part. This is customized. You can do based on the form and size, but the size of the part, which is smaller size, or it should not exceed higher stress should not come. You have to calculate it should be a level stress that you have to get. Frictional resistance and lubricant, you know, due to the frictional resistance, the power losses will be there. So to minimize this one, proper lubrication also should be done. This designer should also know that. Convenient economical fixtures, you have to see based on this convenient and economical fixture, you have to also adopt use of the standard parts. So market whatever existing the standard part is there, you can take and use. No need to again redesign this things. Example, the key, shaft, and gears. These are all available in markets, and you take and adapt in your design. And safety operations, this is also most important for the operators. A machine designer should also ensure that there should be no harmful dangerous operating condition is available in that things. Okay. So next, in the workshop facility, then designer should have aware, should have a knowledge that what is the limitation of the workshop facility and what is the existing design available. The number of machine to be machine, if number of machine component will increase, then the production cost will decrease. But you have to ensure so that. But sometimes 1 or 2 specimen you can do, but that is within the with high cost, but this special manufacturing effect you have to get. The cost of construction, that is very important for the this one. You have to take the ensure the cost should not be high, and assembling should do in appropriate ways where all the available resources will be there. So friends, in this lecture, the end of the lecture of this lecture, the student will be able to the general procedure of machine design. What is the procedure you have to using in the general machine design, and types of load, and stress and unit and problem. So types of loads we can see that the dead load and steady loads, live load and variable loads, or suddenly applied or shock loads, and impact load you have to study, and stress, different type of stress you studied in strength of material. Just this is overview. There's tensile stress and compressive stresses, and it is unit, and you will do how the application in the designs. Okay. So general procedures in the machine design. What are the procedures we are adopting in the machine design? Just to see. This is the flow diagrams. Is generally all in standard books. This is following. First, you should know what is the need of the design. What is the aim of the making the product, or the element what we are making the design. What is the aim and the need? First, you have to know. Then what is the synthesis? What is the mechanism involved in that? Then after that, we have to analysis of the process. You have to do the analysis of the process, forces. Then material selection, it is very important parameters. After that, designing of element you have to do, and size and stresses you have to calculate. If required, you can do the modification, and after that you have to detailed drawings, you have to do drawing, you have to release, then you will start the production. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 9 steps is involved in the machine designs. So we'll see what is the need and what is the aim of this element to designs. Recognition of need. First of all, we'll make the complete statement of the problems and indicate the need and the aim and purpose for which the machine is to be designed. Machine means there is one element or machine. For why what is the need, what is the purpose. You have to write first statement, complete statement. Why you are doing, okay, why you are doing, what is the need, what is the aim, you have to know. After that, mechanism, select the possible mechanism or group of mechanism which will give the desired motions. So after that, you have to see that based on the need, then you have to see that which type of mechanism you can use, which will give the desired results for that need. Then after that, analyze the forces. You have to do find the force acting on each member of the machine and the energy transmitted of each member. You have to calculate the forces acting on each element of the mechanism. In this way, you have to go. Then based on this one, you have to calculate the material selection. You have to select the best material suitable of each member and member of the machine. So fourth is the material selection. First, you know the need, you have to write aim of this one. Then which mechanism is suitable to fulfill the aim. After that, each member, how much force is coming, you have to calculate. After that, you have to go to the material selections. You have to do the appropriate materials which is suitable for this analysis. Example, I can tell you that suppose the cast iron is there, aluminum is there, MS is there. Based on the strength of the materials, you have to select how much stress. Suppose stress is equal to 100 MPa is coming, then you have to select some material that its allowable stresses or its yield stresses or ultimate stress of the material should be more than 100 MPa. Like that, you have to select. The design of elements. What is the design of element and size and stress? Find the size of each member of the machine by considering the forces of the member and permissible stress of the material used. It should be kept in mind that each member should not be deflect or deform in the permissible limit. So that is also main important of design of element. What you have to do here, then after that you have to do size and stresses. After that you select the material, then again you will calculate based on this stress calculate, then you have to make the size. What is the component size, the dimensions of the component you have to calculate, and that should not be more deflected, deformation, the stiffness of this element should be within the permissible limit. Then after that, if required, you can do the modification. Modify the size of the member to agree with the past experience and judgment to facilitate the manufacturing. The modification may also necessary by considering manufacturing to reduce the overall cost. So after that size, after that design element and sizing, then if possible we can do the small modification to overall cost, you can reduce that. Then after that you have to do the details drawings, draw the details of drawing of each component and the assembly of the machine with the complete specification of the manufacturing process need. Okay, you have to do that. The details of drawings and drawing details of components and the assembly of machine components specification of the manufacturing progress. After that, the production you have to do. The component as per the drawing is manufactured in the workshop. So friends, first you have to what the need you have to know, what is the aim of this machine you have to know. After that you have to do which mechanism is suitable for this one. Then you have to do the analysis of forces. After analysis of forces, then you have to see the appropriate material selection, which material is best suitable for this particular stresses, industry the strength point of view or stiffness of point of view, or maybe durability or hardness. What is the requirement? Based on this you have to select the materials. After that you have to do the design of the element. You have to see the design of elements, means that you have to size and stress you have to calculate. Based on this size, based on this stresses, you have to size or the dimension of the machine elements you have to design, and if you require you can do the modifications to make the overall cost should be reduced. After that you have to do the detailed drawings, you have to do the details drawings and complete the specification of manufacturing process as suggested. After that you have to give the productions, you have to do the component as per drawing is manufacturing in the workshop. So friends, we will do here the loads. Okay, in the engineer practice, the machine parts is subjected to various types of forces, maybe due to one of the following: one, energy transmitted. When the energy is transmitted, there is subjected to various forces, or weight of the machine. Due to the weight of machine, there are forces also coming. There may be frictional resistance, or maybe inertia of the reciprocating parts, or such change of the temperature. Due to change of temperature, some load is experiencing on the machine element, or lack of balance of the moving parts. Due to the unbalance of the machine parts, the load will come to experience in the element of machine elements. So there are so many types of load may become, but before that the different forces acting the machine part produce various type of stresses. Okay, we will discuss some of these in this chapter, so no problem. We will see the what is the loads. The load is defined as the external loads, means the external forces acting on the machine parts. The external force if you act on the machine parts, that is called the loads. So, or the load, the external loads causes the internal stress in the elements, and these stresses must be determined accurately since they will be used for determining of complete size. Okay, means I will tell that suppose this is a material is there, you will apply the loads like this, there will be internal resistance will be developed inside. Suppose P you are applying, so a resistance developed by this inside. But what is the load? You can tell the load is on external forces. External forces, this is the external forces. External forces acting upon machine parts. The loads may be okay. This one. So the loading may be due to, I already told, there may be the energy transmission of machine member, okay, maybe dead weight of the machine, or maybe inertia forces or thermal effect or frictional forces. Okay. So in other words, the loads may be classified as one is static loads, one is dynamic loads. What is the static load and what is the dynamic load? The load which does not change the magnitude and the directions normally increases gradually to the steady value. So in the static load, a load is said to be static when it is not changing its magnitude and directions, but normally it increases to the certain limit. See, if you are taking the load this axis and time this axis, the load and load's magnitude and direction is not changing. So if you are applying the load like this, it is gradually it is increasing to a certain limit. After that it is constant. So then that is one is, other one is dynamic loads. The changing the magnitude means that the changing the magnitude both may be load or magnitude changes and maybe also direction also changes. That is called the dynamic loads. Changing magnitude, that is a traffic waiting passing the bridge. Suppose this is the bridge is there. So this is the bridge is there. Okay. If traffic is there, lot of people will stand on this bridge. Okay. If traffic is not there, less people will stand on the bridge. So it is varying with respect to time. That is, you will call the dynamics direction. And it is changing also direction. The magnitude and direction is changing. That is the load on the piston of the rod and double acting cylinder. So you know that in ICE engine, that the load will be very, because sometimes it will be in the double acting cylinder, what will happen? One side will be power stroke and the other side also will be power stroke. So one side power stroke is there and the other side also power stroke is there. Means one side is tension force will act, other side will be compressive force will act. Simultaneously, if you will one time if you arc one side of the piston, other side one time of the other piston. So it is changing the direction. Okay, that is called this one. So if you see this is dynamic loading, and see the with respect to time the magnitude is varying. So load is the varying. Here also see the magnitude is varying and okay, magnitude and the direction also. See if this is also, suppose this is load, this is time, the magnitude and direction also is changing. It is positive to negative. The positive sign to negative sign is changing here. The load is tension nature this side, the compressive nature this side. So it is changing both magnitude and the directions in dynamic loads. Okay. So next, the suddenly applied or shock load. Suddenly applied a load is said to be suddenly applied or shock load. When it is applied, is suddenly removed. Okay. A load is said to be suddenly applied when it is suddenly applied. Suppose suppose it is there. Suppose this is a one material is there. So it is a one bar is a guiding bar is there, and we are applying the loads suddenly. It will like impact loads. Suddenly applied is nothing but the impact. Suddenly with less time, it will go and strike in the bar. That is suddenly applied. The impact load, a load is should be impact load when it is applied with some initial velocity. If you are applying some initial velocity, then you can tell the impact load. If you are not velocity there, just you are giving the suddenly you are applying the loads, that is suddenly and impact, there is a difference there. A load is said to be impact when it is applied with some initial velocity, that is called impact load. Suddenly means you are applying some suddenly and impact, that you should not be confused. Suddenly means when it suddenly applied or removed loads. Okay, impact means with the certain velocity you have to give, that is called impact loads. Okay, or that is also sometimes you can consider the dead load, means a load is said to be dead load when it does not change its magnitude or direction, that is also called static loads. Okay, when the load is said to be dead load or steady loads or static load, means a load is said to be dead or steady loads when it does not change the magnitude and direction of the loads, that is called dead and steady loads. And the live or variable or dynamics loads you are telling, variable when it is changing continuously, it is the magnitude of the loads is changing, magnitude and the direction is changing, that is called live or variable load. Suddenly applied or shock loads, you understood that when it is applied would be suddenly removed or suddenly applied. Impact load, a load is said to be impact loads when it is applied with some initial velocity, when it is applied with the initial velocity. Now friends, already you know that in strength of material you have studied that is what is this stress, working stresses, yield stress, ultimate stress and factor of safety. But as per your syllabus it is there, just this is briefly you have to tell, and then only you will be able to do the designs. Based on this in your syllabus it is there, we have to know that working stress and yield strength are ultimate factor of safety. Before that we have to go that what the stress, you know that whenever some external forces acting on the body, it will deform and there will be internal resistance will develop which is equal and opposite set of which will oppose the deformation. That internal resistance for the unit area is called the stresses. The internal force in unit area of course is known as stresses. So means I want to tell that when a body is subjected to a load, it will deform, and at the same time and there is a internal resistance will develop on the inside the body which is equal and opposite, that will resist the deformation of the body. The resistance force for a unit area is called the stresses, and you know that the P is equal to R. So P is equal to applied load is equal to internal resistance. Internal resistance will be set up inside the body is same with some up to some equilibrium within elastic limit. Okay, with elastic limit P is equal to R. Or the proportional limit. Once it will be the P will be exceed the R, then the L it will be permanent elongation will start. But our machine design of all we are working within the elastic limit. So here resistance developed by body is equal to the external resistance. So the stress is equal to the internal resistance is nothing but the applied force P by A is equal to cross sectional area. A is equal to cross sectional area. Suppose you are the round bar, this is called the cross sectional area. Cross sectional area is equal to, we can tell circular bar is there means pi by 4 d square. If this is a rectangular bar, if you are taking this a rectangular bar, okay, then this area is equal to, suppose this is B is width and D is depth, area is equal to B into D. So stress is equal to load force by area, and it should be, so unit to be Newton force, then area will be m meter square or mm square or kgf by mm square, like that it would be unit. Okay, means whenever in some external forces, whenever a body is subjected to some external load, there will be it will be deformed, and there is an internal force will be developed inside the body due to the coercive forces of the molecules that will stop the deformation, that will resist the deformation. That resistance forces for unit area is called the stresses. So friends, you know also one this is the stress unity. Stress unit, you know that Newton per mm square, like that you know that. So here also some bigger units also available. 1 MPa. 1 MPa means a megapascal. Mega means 10 to the power 6. 1 Pascal is equal to Newton per meter square. Okay, 1 meter square. That is equal to 1 MPa is equal to 10 to the power 6 Newton meter square, or that it will convert Newton per mm square, that is 1 Newton per mm square. So how it is happening? I will tell you here. 1 MPa is equal to 10 to the power 6 Newton per meter square is equal to 10 to the power 6 Newton. So a meter means I can tell this is 1000 mm to the power square. Okay, you can do that. What is coming? 10 to the power 6 Newton by 10 to the power 6 mm square. Okay, you will cancel this one. What is coming? 1 Newton per mm square. So friends, whenever I will tell 1 MPa, direct you can convert it to 1 Newton per mm square. So this you keep in your mind whenever I am telling this one. Okay. Similar, if you do 1 GPa means one is that is called the gigapascal. Giga means 10 to the power 9 Newton per meter square, or that you can tell that kilonewton per mm square, means what is coming that. So 1 GPa is equal to, what is happening? I can tell 10 to the power 3, 10 to the power 9 Newton per meter square. So I can tell 10 to the power 3 into 10 to the power 6 Newton per mm square means what? 10 to the power 3 this is MPa, 10 to the power 6 Newton meter means MPa. This is nothing but we can tell Newton per mm square, right? We can already we did that Newton per mm square. So 10 to the power 3 means we can tell kilo Newton per mm square, kilonewton per mm square. Like this we have to remember. Okay. So friends, what is the strain? You know that what is the strain? The strain is when a system of forces or load act on a body, it undergoes some deformation. That information for the unit length is known as unit strain, or this is called the simple strains. Okay, that is called simple strain. Strain is equal to, suppose this is a body, or apply the load like this. Okay, due to this one, it is due to this one. Suppose this L is equal length of the bar, the P is equal apply the loads. Okay, apply the load like this. So due to this one, P is equal to, due to this one, suppose the length was this one, so L is equal length, due to this one it is increasing, that is suppose del L is equal to increasing. So this is the final length, L is equal to final length. This is L0 is equal to initial length, this is final length. Final length is equal to original length plus dl, this is change in length. This much is change in length. So what is the strain? The strain that is equal to epsilon is equal to change in length. The change in length is equal to how much? The final length minus original length by original length. That L minus this much is equal to del L. That is called del L by L0. So suppose L del L change in length, if you are taking the unit is mm, divided by original length is also mm. So you will cancel this mm. So strain has no unit, strain has no unit, strain has no unit. Okay, this is no unit. So means the strain is defined as it is a ratio of the change of dimensions to the original dimension. It may be increasing the length due to application of forces, okay, this two direction, or sometimes what will happen due to the compressive forces, it will decrease the length, it will shorten. That time also this strain is equal to change diameter by L, or diameter or length, okay. Diameter you are taking lateral strains, okay, Poisson's ratio. So you know the tensile stresses. Tensile stress is developed due to tensile loading. If you apply the load in the pulling, this is like a pulling load. If you apply, then there will be change in the length, increasing the length. In that connection, the stress induced is called the tensile stresses. Tensile stress is equal to P by A. Similarly, if you apply the load equal push, both opposite, due to this one, it will shorten the length. The length of the bar will be shortened. It will be smaller side. The length will be shortened, and the stress induced is equal to the compressive stress, and stress is equal to P by A. And this is the cross sectional area of this bar. Okay. Then the Young's modulus or modulus of elasticity. You know that what is the Hooke's law? Also you know that when Hooke's law, you know that it states that when a material is loaded within elasticity, the stress is direct proportional to strain. That you know that if you within elasticity, this is suppose stress, this is strain. If you apply the load, if you go to loaded within elasticity, the stress is direct proportional to strain up to elasticity. Okay, the elasticity stress is direct proportional to strain, and it will remove this proportional constant and proportionality symbol. Then it will constant will come, that is called E. That E is equal to stress by strain. Okay, and the E is equal to the Young's modulus or proportional constant, that is called the Young's modulus. This is called Young's modulus. Okay, Young's modulus, and E is equal to sigma by E, and this is stress is equal to sigma, and the stress is equal to P by A, and strain is equal to del L by L. So L is equal to up, then it is going to PL by A delta L, or you can del L is equal to, you can tell that PL by AE, PL by AE. You can get the PL by AE. Okay, this you remember that. This you remember that. Okay, del L is equal to PL by A. Okay, in this direction you can find out the change in dimension also. So this P by A and strain is equal to del L by L. Top it will go, it will make like this. Del, you know that in strength of material also, remember that. So friends, the Young's modulus is a constant for the materials. Okay, so it is given for the steel, it is around 200 to 20 GPa. So we are telling that 210 GPa we are using frequently, and wrought iron it is giving 190 to 200. Cast iron is coming 100 to 160. Okay, and the copper 90 to 110, brass 8 to 7, and aluminum 60 to 80, that you are using 70 GPa frequently, and timber that is 10. Just you keep in mind that you are using steel frequently 200 steel, and aluminum you are using frequently. Okay. So friends, we'll do here some these problems. Just you see that we will do the start some basic designs. Okay. A coin chain of this coin shape required to the crank required a carry a maximum load of 50 kilonewton as shown in the figure. Find the diameter of the link stock if the permissible tensile stress of the link material should not exceed to 70 MPa. Okay, what he has given that he is making that you have to calculate the diameter of the link. Okay, diameter of the link stock, it should not fail. Okay, so what is given that you write here the solution. What is given that? What is given? The P has given. P how much is given? 50 kilonewton. 50 kilonewton you convert to Newton, 10 to the power 3 Newton. Okay, and he has given that maximum stresses, the tensile stresses of that should not exceed 75 MPa. Means what is 75 means? 70 Newton per mm square. It should not exceed. And calculate the diameter. You calculate the diameter of this one. So no problem. We know that see the stress is equal to what? Load by area, right? Load by area. Or we know that. What do you know that? Total maximum loads. We know that maximum load is equal to P is equal to T sigma T into A. I will use this frequently. So load when you will stress into A. Okay, remember that. You just see what is the area you can calculate. Area of this is like a circular. So pi by 4 you can take into d square. So how much is coming? Is equal to 0.785 d square. Okay, if you put this one, so how much load? Load you know that 50 into 10 to the power 3 is equal to stress is given 55 into how much? 0.785 d square, right? Now here what is unknown is there? The unknown is here only d. So based on the d, you can calculate what is coming the d square. D square is coming 850. So you can calculate d is equal to how much is coming? 29.13. We can allow the design, you take just little higher side, that is 30, you make it 30 mm. So if you will make one 30 mm the link stock, then it will not fail, and if will take it can take 50 kilonewton loads. Means the he has given the permissible stresses, and if you take the diameter around 30 mm, if you taking, it can take the 50 kilonewton loads. Okay, it can take a 50 kilonewton loads. Like this we can calculate. Okay, simple problems we can do like that. So friends, one more problem we will do here. He has given that, we will make the solution here. What is given that a hydraulic press exerted total load of 3.5 meganewton. The load carrying by the two steel rods supporting the upper head of the presses. If the safe stress is equal to 8 MPa and the Young's modulus is given, find the diameter of the rod and extension of each length of 2.5 meters. Here what will given? What is the given data you write? Given data what is given? no problem, you write the hydraulic load he has given that P is given 3.5 mega Newton. So what is giving 3.5 into 10 to power mega means 6 Newton, and he has given the self stresses, tensile stresses he has given that 85 MPa. 85 MPa is equal to what? 85 Newton per mm square, and he has given the Young's modulus. What is given Young's modulus? Young's modulus is 210 kilonewton per mm square. You can calculate this one, 210 into 10 to power 3 you put Newton per mm square, you write. And he is asking to find the diameter. We will see first the diameter of the rod. Diameter of the rod. We know that diameter of rod is calculated. Hydraulic exact total load of this one. This load is carried by two steel rods. So means suppose the hydraulic press is there. This is a hydraulic press is there. Okay. Okay. This is two rods. To rod 1 and rod 2 is taking a load of 3.5 mega Newton. Okay. Rod 1 and rod 2, it is taking the two rods. Let we will take that D is equal to the diameter of the rod. Okay. Suppose the area is equal to how much, you know that pi by 4 into D square. How much is coming? You will calculate 0.7854 D square. Okay. Then since the load is carried by the two rods, right? Therefore the load carrying by each is equal to, if a load is, suppose you are applying the load here, it is taking by one is half of the load is taking by this 1 and 2. So I can write here this one. Since the load carried by two rods, therefore we can take that the load carried by each rod is how much? Each rod how much? It will be P1. Suppose this is the total load is P. This will take this P1 is equal to P by 2, and this will take the P by 2 is equal to P2 is equal to P by 2. So it is taking P1 is equal to P2 is equal to P by 2. That is called 3.5 into 10 to power 6 by 2 is equal to 1.75 into 10 to power 6, that is called the newtons. This much load you will take. Now you know that I can tell you that we can tell that the load carried by each rod, suppose P1 is equal to P1 load is equal to stress into A. You can calculate. Now load you know that 1.75 into 10 to power 6 is equal to stress is equal to 85 into the area you know that 0.7854 D square. From here that unknown is only D. So D is equal to, it is coming around 162 mm. This is the answer. Okay. Since now what is here? It is taking the two members the load is taking. So each member is taking by load is half of the total loads. Then that load you come and check with this tensile stress into area. Then you can calculate the diameter. Then he is telling that what is the extension of each rod. Extension of each rod you can know that DL is equal to P1 by L by A E. This you know. Now del you know that area you know, and L also you know, and E also know, and area also we calculated that also. Since area you can know, area also you know that since diameter you calculated, there you can area is equal to pi by 4 into d square is equal to, right, pi by 4 into the diameter is 162 square, that you can do here. So P1 is equal to, you know that, what is the P1? P1 you know, and the area you know, P1 you know, or you can the P1 by A1 you can tell, that is direct, you can tell this is a stress, you calculated from that. But stress is equal to P1 by A you calculated, no, you can put that stress also, you can put by E by L, you can put that. So no problem, here also the stress is equal to 85 mega a Newton meter into L is equal to, he has given 2.5 meter, means 10 to the power 3 meg, divided by the E value he has given, that 210 into 10 to the power 3. So how much it will come, that it will come around 1.012 mm. Okay, like this we can calculate, or you can tell del L is equal to, you can put the P value, you know that 1.75 into 10 to the power 6 divided by pi by 4 into d square is equal to 162 square into E is equal to 210 into 10 to the power 3 into L is equal to 2.5 into 10 to the power 3. You will do also this calculation also, you can do 1.012 mm. Okay, in this way you have to do the designs. Okay, so thank you very much for watching, then we will meet in the next lectures.